Good afternoon, everybody. Welcome to the last Monday. It is the last week of class, the last Monday of Chem 1105 with your host, me, Dr. White. Hi, everybody. All right, a couple of things I should tell you over the weekend, because I guess the age of two of my computers, I had to have C drives. Hold on one second. Let me fix something. Sorry about that. Had to fix something. There's some wires that look sort of Anyways, both of my main computers, I had the C drives replaced, and that was a lot of work. And luckily, everything's working okay, other than I wonder if my image here is a little larger than normal. We'll work on that tomorrow. All right, lots to do today. First of all, let's go to Blackboard. And the first thing I want to remind you is this Thursday, I will be giving the final exam. By 8 a.m., probably even earlier, I will send out an individual or email with the password for the final exam PDF file. You'll have until Friday, and notice the time is different, till 2 p.m. to finish the final exam. That means you've got more than 24 hours to take the final exam and upload it to the assignment area D2L. Remember, it has to be a single PDF file. Realistically, it should take you about 60, 70 minutes to finish it. But if you need up to 3 hours, go right ahead. Checking my camera there. And the final exam will cover the whole semester, and it will have 27 problems, 8 pages. Some of the problems are multiple part. There's 5 multiple choice. Test material. From test 1, there's 16 points. I should say final exam material. From test 1, 16 points. Test 2, 44. Yep, there's a lot more points on test 2. Test 3, 29. Test 4, 21. It adds up to 110. So there's 10, 10, yes, 10 bonus points. And make sure you hand it in time and properly, because if you don't follow instructions, I reserve the right to subtract up to 50 points, and I will, because I'm under a deadline to get your grades in. All right, by Sunday, 1 p.m., give or take an hour, I should have all the points, your final exam, and everything else in Blackboard, including your grade. Now, I will also be entering your grade into the COD system. I think it's My Access. It's ECC and COD have similar names. I get them confused sometimes, but it may take up to 24 hours or a little more before you see it in that. But whatever I have in Blackboard will be your official grade. Let me remind you, since I'm giving the final on Thursday, there will be no Zoom meeting this Thursday. All right, that's the first thing. Next thing, I would like to talk about lab grades. And some of you are a little late in getting labs in and still are because of problems you had getting the kit and other problems. All right. Yesterday, I spent a lot of time going back, checking old labs and making sure I was up to date. Right now in Blackboard, as of yesterday, 11:30 a.m., I have graded all labs that were uploaded by that time in Blackboard, except for labs I could not open. And there are a few people who did that. Please check your lab scores in Blackboard. If you have a lab that has been uploaded as either a PDF file or MS Word file and has not been graded, please let me know via email. Make sure that all ungraded labs were uploaded as either a PDF or MS file, Word file. If the lab was not the correct file type and it wasn't graded because I couldn't open it or read it, please upload that lab or labs as a PDF or MS Word file and send me an email which labs you uploaded. This is important. The deadline, I've mentioned this before, but I'll mention it now. The deadline for all labs is Tuesday, tomorrow, August 1st, by 11:55 p.m., the end of the day. After that, all labs that have not been submitted for grading will be given a 0 score. So make sure you've got today and tomorrow, get those labs uploaded. You've had plenty of time. I told you this a couple weeks ago. All right, let me remind you, the extra credit project is due, or not due, deadline is tomorrow also at 11:55 p.m. It's optional, but if you do it and do it right, it's 10 bonus points. Yes, 10, 10, 10 bonus points. All right, I think I'm up to date, except one more thing, actually two more things. One is you should have received from COD via email a link or some, I don't know how they do it, through Blackboard for student evaluations. Please do one for me. Also, if you like what I did this semester, and remember, this is an internet class. I didn't have to post videos or have lectures, but I did because it helps you do well. And with that in mind, I'd ask you to go to ratemyprofessor.com if you like what I did and write something. And if you didn't like what I did, you can also go to ratemyprofessor.com. Now, let me try this one thing. That's better. All right. The other thing, if you really, really like what I did, or if you really, really didn't like what I did, please send an email to the president of COD, Dr. Caputo, and copy the board of trustees. And let's go to Blackboard again. And let's go to student view and make sure I did turn it on. If you look on the left of Blackboard, you'll see now important email addresses. If you click on that, you'll see two files. And let's open up the PDF file, and you'll see important email addresses. One is the president of COD is Dr. Brian Caputo, and there's his email. And he does read his emails from students and faculty too. And here's the email for the board of trustees. So if you really, really like what I did, send them an email, let them know. If you really, really didn't like what I did, well, you can send them an email too. Now, I would give you an advice. You're going to send them an email, write it, let it sit overnight, read it the next day. And then if you don't think you have to make any changes, send it. The other advice, send it to Dr. Caputo and copy CC the board of trustees. When you write an email to Dr. Caputo, I would highly recommend you start off, Dear Dr. Caputo, or Hi, Dr. Caputo. All right, any questions? All right, what I'm going to be doing first is I'm going to go over test number 4. By the way, thank you, thank you, thank you. My heart says thank you too. All of you did really good on test number 4. And you know why? Because there was less math, or also you studied hard, or the combination of the two, which I'm going to go through. Afterward, I'm going to start my review for the final exam for the whole semester. What I'll do is go through parts of each test review and do some practice problems today, tomorrow, and Wednesday. Remember, we've done all the labs, get them in. The deadline is tomorrow, 11:55 p.m., end of the day. All right, let's go through. And now we're done with the test. Now, if you look in Blackboard, you'll see I also have your test total there. That's the sum of the 3 highest tests. And if you're wondering what kind of grade you're getting right now, hold on one second. If your test total is 270 or greater, you're getting an A right now. Hold on one second. Let me do something smart, which I should have done before. Be within a second. All right, sorry about the delay. Let's try this, see how it looks. All right. Let's make sure you're seeing what I'm seeing. You are. All right. If you got greater than or equal to 270, right now you're getting an A. 240 to 269 is a B. 210 to 239 is a C. 180 to 290 is a D. And less than or equal to or 179 would be an F. So this gives you an indication where you are. Now, these letter grades are assuming you've handed in all the labs. If you haven't, add up all your points, divide it by the total maximum number of points. Your 3 tests are 300, and each lab would be 1,220. So that would be divide your total at this point by 420 multiplied by 100. And if you get a number greater than 90, it's A, 889, B, and so on. All right, any questions about test number 4? Okay, well, in that case, I'd like to start the review for the final exam. Let me remind you, the best way to practice for the final exam is use your test 1, 2, and 3, and now 4 as practice problems. Will I write the exact same problems? No, I won't do that, but I will write similar ones. Just look at the practice problems all semester. They were similar to what you saw on the test. And let me open up something. All right, remember this, what you're seeing on the screen is available in Blackboard in the lecture section of Blackboard for this class. Now, remember there are 4 branches of chemistry. The best one is organic because I'm an organic chemist. And then, let me move this over here. And then there's also physical, analytical, and inorganic. Now, matter is anything that has mass and occupies space. Now, at this point, I asked you to learn the chemical symbols and names for only 37 of the elements. And as you've gotten all semester, I will be giving you, and you'll be using this periodic table. And you should know, like H is hydrogen, Li lithium, Cl chlorine, O oxygen, and nitrogen, C carbon. And remember, if there are 2 letters, the first one is always capitalized, the second one is smaller case. In this case, Na sodium, Mg magnesium, Ca calcium, or nickel, Ni, Pd palladium, PT platinum, ooh, the expensive stuff, Au gold, Au silver, I'm sorry, Au gold. Now, I talked about the states of matter, and you should know there are 3 states of matter: solid, liquid, and gas. And the solid has definite shape and definite volume. You should know that. A liquid, indefinite shape, definite volume. And finally, a gas, indefinite shape, indefinite volume. Now, when it comes to matter, there are two types. One is a pure substance, and the other is a mixture. Now, a pure substance can be an element or a compound, and a mixture can be homogeneous, the same throughout, like salt and water, or gasoline, or the air you're breathing, and heterogeneous is not the same throughout. I won't do it, but if I were to put sand in my water bottle, shake it up, and just let it sit for a minute or two, all the sand would be at the bottom and the water would be up here. And that would be a heterogeneous mixture. Now, I don't have it on here. Maybe I do and I forgot this later on, but you should understand empirical formulas, how many atoms are in the following compound. And here it's got 1 sodium, 1 nitrogen, and 3 oxygen. So it's 1 plus 1 plus 3 equals 5. Next, when you have a polyatomic ion, which we talked about for test 2, and here we have magnesium bicarbonate. How many atoms total are in that molecule? Well, 1 magnesium, but notice the brackets here and the 2 subscript to the right of the last bracket. That means you multiply everything inside by 2. 1 hydrogen times 2 is 2. 1 carbon times 2 is 2. 3 oxygen times 2, well, that's 6. And how many atoms are in there? 11. Now, I talked about properties of matter, and there are 2 types: physical, things you can observe, and chemical properties that tell you the ability of that matter to change into something else. In other words, react. And a physical property would be a melting point. At what temperature does water melt or freeze? Also, what color shirt am I wearing? That's a physical property. It's red in case you haven't seen it. And other things like that. Now, what would be a chemical property? Water doesn't burn. Paper does. Don't try that at home ever. All right, now, there are changes in matter, and a physical change is a change in state. An example of that would be an ice cube melting, going from a solid to a liquid, or water boiling. That's a change in matter when it goes from a liquid to gas. Now, chemical change would describe how it changes under certain reaction conditions. Example, iron can rust, form ferric oxide, or, I don't have one with me, the wax in a candle can burn because it's flammable. By the way, I should mention Vaseline is really flammable, and you know about gasoline. All right, next I talked about 3 temperature conversions, how to go from degrees F Fahrenheit or from degrees C Celsius to degrees F Fahrenheit. And there's the formula. Now, if you have degrees F and you want to convert it to degrees C Celsius, you use the second formula. And finally, if you have degrees C Celsius and you want to convert it to Kelvin, you use the third formula. These formulas will be given to you, important information, final exam. In fact, let me do this. All right, you see on your screen right now, that's important information, final exam. And as I've done all semester, I've cut down heavily on the amount of memorization you have to do. You have to know how to use this information, but you don't have to memorize a lot of it. And here I have those three formulas. Now, later on, I taught you about exact numbers, but let me remind you, in the first formula, 1.8 and 32 are exact numbers. The second one, 32 and 1.8 are exact numbers. And the third one, 273. So on each of these, the number of significant figures in the first two, the measurement you start with, degrees C in the first formula, degrees F in the second, will be the number of significant figures in your answer. In the last one, it's an addition. The number of significant figures to the right of the decimal will be the same as the number of significant figures to the right of the decimal in degrees C. Now, let's go back. Test number one, review. And next, I talk about scientific notation. That's the number Q times 10 to the N. Q is never less than 1 or 10 or greater. And know how to convert to scientific notation. And one important thing you should know, if the number is greater than 10, then N is positive. If the other number is less than 1, N is negative. And you move the decimal point, or if there were a decimal point, to the right of the first non-zero number. And I'm going to have you try something. Write that number in scientific notation. All right, everybody's done, so it's my turn. If there were a decimal, we move it 1, 2, 3, 4, 5. Without a decimal point, zeros at the end are dropped. 1, 2, 3, 4, 5. So I moved it 5 times, and this number is greater than 10. So that'd be 1.25 times 10 to the 5th. If I look at the clock, time flies when you're having fun with chemistry and Dr. White. It's time for a 5-minute break. I'm going to take a 5-minute break. I'll see you in 5. I'm going to get up and stretch. Oh, that's better. Time to get going. All right, we're going through the review for test number 1, which will help you for the final exam. And we're doing scientific notation. Let's do one more example. And why don't you write that number in scientific notation? All right. Now, this number is less than 1, but you still move in. There is now a decimal point to the right of the first non-zero number. 1, 2. All lead zeros are dropped. And then, since we moved at 1, 2, n is negative. So that's 3.12 times 10 to the minus 2. Next, I talked about significant figures, which are an important part of chemistry. And on my test, when you use certain multiplication, I'll talk about that. The first thing you have to do is determine how many significant figures each value you're operating with is. And the rules, I'll never ask you the rules, but you need to know how to do this. All non-zero numbers are significant. Lead zeros at the beginning of a number are never significant. Confined zeros, those between numbers, are significant. Trailing zeros at the end of a number are significant if a decimal point is present. And trailing zeros, those at the end of a number, are not significant if the number lacks an explicitly shown decimal point. And the question would be, how many significant figures in the number I just wrote on the screen? And it looks like everybody's done. If you need more time in watching the video, hit the pause button. And this number has 1, 2, 3 non-zero numbers. And here we have a 0. It's after the decimal, which would make it significant. And it's also confined between two non-zero numbers. So the answer is this has 4 significant figures. And that's the skill you should have. Now, I talked about rounding off, and we've done this enough, and that is if the first digit to be deleted is 4 or less, simply drop those and all afterward. If the first digit to be deleted is 5 or greater, you drop that digit and all that follow, and the last remaining digit is increased by 1. And why don't you round this off to 4 significant figures? I'll let you do it, and then I'll do it. All right, my turn. When we want to round it off to 4 significant figures, keep the 2, keep the, hold on 1 second, let me get the larger. Keep the 2, keep the 4, keep the 7, keep the 6. That's my 4 significant figures. The next number I round off. Is that 4 or less or 5 higher? And 5 higher. So that means I drop this, increase this by 1. Don't forget the exponent here, 10 to the 3rd, and that's how you do it. Now, the reason you need to know significant figures and rounding off are when you do multiplication, division, or addition. I don't think we had any major subtraction other than exact numbers in this class. But anyways, for multiplication, division, you get the same number of significant figures in your answer as the number that has the fewest significant figures in your answer. And for addition, you get the same number of significant figures to the right of the decimal as the number that has the fewest significant figures to the right of the decimal. Remember, exact numbers are not considered when determining the number of significant figures on a math operation. Hold on, water break. Now, a lot of you this semester have been losing points because you're not doing significant figures when you do a calculation on my test. On the final exam, it will say under your name, please use proper significant figures for all calculated answers. And if you don't, I'll take off a point. If you have 5 or 6 of those, that's 5 or 6 points you've lost. So please use proper significant figures for all calculated answers. Oops, wrong thing. Right thing. Next, I talked about the periodic table, and there's certain names you should know. And those are the alkali metals, the alkaline earth metals, the halogens, noble gases, and know at least an example of some of the elements that are metals. And if we look at the periodic table, the first column, not including hydrogen, are the alkali metals. The second column, which contain Mg, magnesium, Ca, calcium, are the alkaline earth metals. And you should know that. And the second to the last column with F fluorine, Cl chlorine, Br iodine, Br bromine, I got ahead of myself, I iodine, those are the halogens. And the last column, He helium, Ne neon, Ar argon, Kr krypton, and so on, those are the noble gases. And on test 1, I did ask, give an example of, say, an alkali metal, and you could have put down lithium, sodium, or potassium. Give an example of a halogen. You could have put down, I asked both the chemical symbol and the name. You could put down F fluorine, Cl chlorine, and so on. Know these. Now, I started getting into some chemistry finally. And we talked about the atom. And the atom is the smallest particle of an element, and that contains all the properties of that element. You should know what are atoms made up of, and they are the subatomic particles. The first one, electron. The second one, proton. And the third one, neutron. And you should know an electron has a minus charge, proton plus charge, and a neutron, no charge. And where are the protons and neutrons? They're in the center of the atom called the nucleus. And we learned about the fact that the nucleus is a very dense center of an atom by Rutherford's gold foil experiments, where he shot those high energy particles, probably really a grad student, and some of them bounced back or were scattered. That's like shooting a cannonball at a piece of Kleenex or tissue paper or puffs, pick your brand you like, and it bounced back at you. All right, next I talked about the atomic number. And the atomic number you should know equals the number of protons in an element, since all atoms of elements have a net zero charge. The number of protons in an element also, which is the atomic number, also has to be the number of electrons. Now, if we look at the periodic table, where is the atomic number? In the upper right-hand corner. For lithium, it's 3. That means it has 3 protons, 3 electrons. For my favorite, carbon, C, over here, it has 6 atomic number, so it has 6 electrons, 6 protons. If we go over another good one, oxygen, atomic number 8, it has 8 electrons, 8 protons. And if we go to the high rent district, AU gold, that has 79 for atomic number and 79 protons, 79 electrons. Now, where are the electrons? Remember, the protons and neutrons are in the center in the nucleus, but the electrons are in the shells and subshells around the nucleus. And the electron shells have names, and they are 1, 2, 3, and 4. And the number of subshells in shell 1 is 1, 2 is 2, 3 is 3, 4 is 4. Now, subshells have letters. Actually, subshell real name is both a number and a letter, but the individual subshells in general go by the name S, P, D, and F. And S subshells, whether it's 1s, 2s, 3s, can have a maximum of 2 electrons. P, maximum 6, D, 10, F, 14. Now, you should remember, so I didn't put it on here, and I'll show you in a second. Hold on. And here, shell 1 is the lowest energy, and as you go down that table, you have higher energy. And same thing for the subshells. S is the lowest energy. And F is the highest energy. And I asked you to learn electron configuration. That's a statement about how many electrons an atom has in each of its subshells. Remember, a subshell is a number and a letter. And when you do electronics, you have numbers, electron configuration. You have numbers and letters only. If you look at important information, I think I forgot. I'll have to change this. I forgot the shells and the subshells. Bad, Dr. White. All right, and on test number 1, I asked you to draw the electron configuration for a couple of elements. And the first one, or I'll do one right now, is sodium. So the first thing we have to do for electron configuration is figure out how many electrons does sodium have. And we look at the atomic number and see it's 11. By the way, looking at the periodic table, remember my gift. You only have to know how to do electron configuration up to 12 magnesium. So sodium has 11 electrons. And the first shell and subshell is 1s. S, you can put maximum, any S or a subshell, you can maximum 2 electrons, so I will. Well, there's only one subshell in shell 1, 1s, and I filled it up. So I now go to the next lowest energy shell, 2, and the first subshell is 2s. And that also I can put 2 electrons. Well, 2 has 2 subshells, 2s and 2p. Any p orbital, p subshell, you can put up to 6 electrons max. So I will. 2 plus 2 plus 6 is 10. 11 minus 10, I have 1 electron more to go. Well, shell 2 has 2 subshells, 2s, 2p. I filled them up. So now I have to go to the next shell, which is 3, and the first subshell is 3s. Now I can put up to 2 in there, but I only need 1 more, and that's how you do it. Now, finally, in test 1, I talked about the valence electrons. And you should know, what is a valence electron? And that's the electrons that are in the outer, those are the outermost electrons of an element. By the way, they're the coolest because they're the ones involved in chemical reactions. But now I'm being biased. I can do that when we're talking about chemistry. All right, now, how do you determine how many valence electrons an element has? You look at the top of the periodic table for the number of valence electrons. Remember, atomic number gives you all electrons, but if we look at the periodic table, periodic table I give you, the number on top in red tells you how many valence electrons. Underneath that are the Roman numerals, but I found out a number of years ago, most of my students didn't know Roman numerals. And if we look at carbon, symbol C, you get the valence electrons up here, 4. If we look at chlorine, Cl, look at the top, the valence electrons are 7, not the atomic number that gives you all electrons. The valence electrons are just the outermost electron. Now, let me open up something, which I didn't. Got my thing open. Sorry about that. If we look at key problems for 1105 final exam, notice how many electrons and protons are in the following. And carbon, if you look up the atomic number 6, has 6 protons, 6 electrons. Another one, my favorite, sodium, it has, as long as it's not in the cation, sodium metal, the element, has 11 protons, 11 electrons, because it has an atomic number of 11. Now, how many valence electrons are in the following? Oxygen, you look at the top, you'll see on top 6, nitrogen 5, and we did chlorine 7. And that's everything for test number 1. Now, if you notice in tests in the final exam, I only have, I think, 16 points for test number 1. Why? Because I'm not going to ask you round this off or how many significant figures, because you need to know how to do that for any calculated problems. And those were points that were on test number 1. Let me close this. And I had to open up stuff. If we were face to face, you'd be watching me open a file from my flash drive, thumb drive. All right, let's start review for test number 2 material. And this is also fair game for the final exam. And the first thing I taught you was Lewis structures. Now, Lewis structures of elements, you write down the chemical symbol, and there's 1 dot per valence electron. You don't double up until each side of the chemical symbol has 1 dot. So if I were to ask you, draw the Lewis structure, and on test number 2, I did ask you to draw the Lewis structure for some compounds. And let's do oxygen. Whenever you see the name Lewis structure, that means valence electrons. So for oxygen atom, this is oxygen, the element, not O2, because I hadn't taught you yet. what do we do? We come over to our periodic table, and we want the Lewis structure. So we have to find valence electrons for oxygen. There's 6. So we have the chemical symbol. Then we have 6 valence electrons, and we do 1, 2, 3, 4. Now, organic chemists, which I am one, like to put number 5 here and number 6 here. But any drawing, 2 sides have 2 dots, 2 sides have 1 dot would be correct, such as this. Both of these are correct. Oops, how did I get an extra dot there? There we go. 2 sides have 2 dots, 2 sides have 1 dot. Now, next I talked about chemical bonds. There's 2 types, and you should know. Well, I haven't done this all day. I should. Hi, what is an ionic bond? It's the transfer of 1 or more electrons from one atom or group of atoms to another atom or group of atoms. And the other type of chemical bond is the covalent bond. And this results from sharing of 1 or more pairs of electrons between atoms. And I'll never ask on a test what the octet rule is. In compound formation, atoms of elements lose, gain, or share electrons in such a way that their electron configuration is identical to that of the nearest noble gas in the periodic table, which means 8 valence electrons. Now, when a atom of an element loses a electron or electrons, it forms a positive ion called a cation. When an element gains electrons, it's called an anion. Now, atoms, electronians, sorry about that spelling mistake. Electrons lose or gain electrons. They have the same number of electrons nearest noble gas, but electrons never lose protons when forming an ion. And so the question is, what ion does the following element form? Well, how do you do that? Well, for calcium, the chemical symbol is Ca, and we first have to find out how many protons and electrons does calcium have. If we look over here, calcium atomic number 20 has 20 electrons, 20 protons. Now, what's the closest noble gas numerically? And you have neon at 10, which is only 2 away, and argon right here at 18, which is 6 away, which is closer, and neon. Now, you should know neon would have 10 electrons. So how do we proceed? Calcium has 12 electrons, 12 protons, but it wants to have the same number of electrons as the nearest noble gas, neon, which has 12 electrons, but calcium would still have, or 10 electrons, but calcium would still have 12 protons. And remember, each electron is a -1, each proton is a +1. You do the math, and this means there'll be a +2 charge. But I asked what ion, and you show the ion by the chemical symbol and superscript write the charge, +2, which is the older way I like, or the other way, which I would accept on a test, 2+. Now, let's do the same for bromine. Oops, that's not what I wanted. And bromine, a halogen, has 35 electrons, 35 protons. What's the closest noble gas? Krypton. By the way, in our universe, krypton is not a green solid that kills Superman. It's a colorless gas. But anyways, krypton is the closest, and it has 36 protons. The others are much farther away. So to determine what ion bromine will form, bromine has 35 electrons, 35 protons, and the nearest noble gas, krypton, which bromine wants to have the same number of electrons, has 36 electrons, but will still have 35 protons. Do the math. Each electron is -1. Each proton is a +1. And this is 36 times -1 is -36. 35 times +1, add them together, you get a -1. How do you show the ion? Chemical symbol. And when it's a -1 or +1, this show the sign, in this case, Br-. Now, next, write the ionic formulas, otherwise known as the empirical formula from charges, ionic charges. Remember, all molecules have a net zero charge. And here we have what would be the empirical formula of a molecule of calcium +2, chloride -1. And in order to get this to add up to 0, you cannot change the charge, but you can change how many of them. If we have a +2, we need a -2, but chloride has only a -1, so we need 2 of them, and we show the formula 1 chloride, calcium, 2 chlorine. Let's do one more. And the question would be, what's the empirical formula of a molecule with magnesium plus 2 cations and nitrate, the polyatomic ion, NO3 minus? And guess what? I'm going to share the fun. It's your turn. All right, looks like everybody's done. This is a plus 2. This is a minus 1. All molecules have a net zero charge. Well, this doesn't add up to 0, but I can't change the charge, but I can change how many, and now it does. So how do we write this? There's 1 magnesium. Now, when you have a polyatomic ion, more than 1, you put it in a bracket, and then subscript to the right of the bracket, you put how many? 2. And that's how you do it. Now, next I talked about covalent bonds. Remember, covalent bonds are sharing of pairs. That means 2 electrons. And there are 3 types of covalent bonds: single bond, double bond, triple bond. And you should know a single bond is 1 pair of electrons, double bond, 2 pair of electrons, triple bond, 3 pair of electrons. Now, I asked you to know how to draw the Lewis structure of molecules, and that was on test number 2. Go back and look at it. You'll see that question. Dr. White has a photographic memory sometimes. Unfortunately, times when I don't want it, and other times when I do. And let's do a couple. Let's look at H2S, hydrogen cyanide. That's the stinky gas that comes from wells, and also hard-boiled eggs. And as 2 hydrogens, but each one has 1 valence electron. Whenever you see Lewis structure, you're dealing with valence electrons. And sulfur, you look at the top of the column, it's with oxygen, has 6 valence electrons. And the only way this can work is if sulfur is in the middle. Now, sulfur has six valence electrons, and each hydrogen has 1 and says, I've got 1, you've got 1, let's share. And it does. Now, let's look at sodium cyanide. Now, whenever you see an alkali metal or alkaline earth metal, it will never, ever be in a covalent bond. I'll bet money on that. If I say I'm going to bet money on that, it means I know I've won. So sodium has 1 valence electron, but it's always going to be a +1 cation. Carbon has 4 valence electrons, and nitrogen has 5 valence electrons. And Here's our sodium cation. I have a carbon with 4 valence electrons. I have a nitrogen with 5. And carbon says to nitrogen, hey, you have 3 unpaired electrons. I have 3. Let's share. And they do. Oops, wiped out too much. We'll get it back. Now, where did this electron from nitrogen go? It left. And where did it go? It went over to the carbon. Now, the nitrogen carbon has an extra electron, and therefore it's a minus charge. So remember, all elements that are alkali metals, alkaline earth metals, which, let's go to the periodic table. This column, not hydrogen, and this column, magnesium and calcium, always for cations, sodium, potassium, and lithium +1, magnesium, calcium +2. Next, we got into really good stuff. Dr. White was happy then, I'm happy now. And that's a chemical equation. A chemical equation is a way chemists show chemical reactions. Now, for the chemical equation, A plus B makes C. You should know at the base of the arrow are the reactants. At the head of the arrow are the product or products. And you should know this. Now, we talked about balancing chemical equations, and there you can only change the coefficients. My advice, leave hydrogen and carbon last, and remember the even odd trick. There'll be some on the final, so know how to do that. If I ask you to balance a chemical equation on my final, the answer it's already balanced will never be correct. You will have to balance any chemical equation I put on the final. And let's have you do one for a little fun and practice. And your turn. Balance the following equation. C5H12 pentane plus oxygen, you learned this is combustion, makes CO2 and water. So it's your turn to balance it. Have fun. It looks like everybody's done. I'll do it now. Now, I'm going to do carbon, leave hydrogen, oxygen last. There's 5 carbons here. How do I get 5 carbons here? I change the coefficient. You can't change the molecule. You can't. Well, you can, but I'll mark it wrong. So now I have 5 carbons. Next, I have 12 hydrogens. How do I, oh, I only have 2 on this side. How do I get to 12? Well, 6 times 2 is 12 hydrogen. Now on this side, I have 2 oxygen. How many on this side? You count all the oxygen atoms and all the molecules on each side. So on this one, I have 5 times 2, 10 oxygen. And here, I have 6 times 1, 6 oxygen. So on this side, 10 plus 6, 16 oxygen. How do I get 16 on this side? Well, put an 8 there. 8 times 2 is 16 oxygen. 5 carbon, 5 carbon, 12 hydrogen, 12 hydrogen, 16 oxygen, 16 success. Remember, use, and somebody asked me I got it right, and so did one of your colleagues. Yay. But anyways, make sure my advice to you is when you have different atoms, leave hydrogen, oxygen for last. If I look at where we are, we'll talk next about the mole. And I think this is a good time for us, as we're running out of time, for me to remind you, don't forget, 1, tonight from 7 to 8, I will have my office hour. If you have any problems or questions or need help, stop by. It's on Zoom. Next, don't forget, tomorrow, at the end of the day, 11:55 p.m. I could have made it midnight, but I've made it that, is the deadline for you to upload all labs into D2L. Wrong school. Blackboard. Blackboard. I do that every once in a while, and you just caught me doing it. Wrong school, wrong system. All right. Again, you have until tomorrow, end of the day, 11:55 p.m. to upload all labs in Blackboard. And for the labs that need it, don't forget to do your selfie with something from the lab. And don't forget, tomorrow is the deadline for the extra credit project, which is totally optional, but it's 10 bonus points. And with that, tomorrow I'll continue. We don't have any more labs. You're all done, other than to make sure you hand them in. I'm going to say, Gang Gesund. Goodbye now.